All right, good morning, students. Today we're talking about calculating density, but first let me go over the do now. I think most of you have gotten this correct. It says density is defined as the blank. Well, at this point, you should know that density is the mass of an object divided by the volume. Okay, so is the mass of an object per unit volume. Remember, per means kind of divided by. Okay, so our answer should be C. Okay, because you know that the formula for density is mass over volume. Okay, and that's density equals mass over volume. That's mass per volume. Okay, so that should be C. All right, it says here for the do next question, what unit should be used for the volume of a liquid? And for most of our calculations, we're going to use milliliters. Okay, ml. Okay, you might have written it out. Either way, it's fine. All right, and then for the units that we use for a solid, okay, we use centimeters cubed. All right. Now, it says 1 milliliter is equal to how many centimeters cubed? Well, this is the same volume. Okay, so 1 milliliter is the same thing as 1 centimeter cubed, except like we just said, we use milliliters when we're measuring liquids, and we'll use centimeters cubed when we're using solid, or we're measuring the volume of solids. And then there's this question here. Okay, it says we have a 90-gram piece of metal that was placed into a graduated cylinder with 10 milliliters of water in it. The volume of water rose to 15 milliliters after the piece of metal was added. What is the density of the object? Okay, so right here, okay, they're using the displacement method, which we're going to talk about again in a minute, to figure out what the density of this piece of metal is. Now, we already know that density is equal to the mass of the object divided by the volume. It tells us in the question that the mass of the object is 90 grams. Okay, but it doesn't give us the volume. But what it does tell us, now you can't just start plugging in numbers. You have to actually read. Okay, if you started just looking at these numbers and trying to do some math, then you might have gotten the wrong answer. But just to help you visualize, they're saying there was a graduated cylinder, okay, and it had 10 milliliters of water in it. Okay, then they put in some piece of metal into here, and then it rose up to 15 milliliters. Okay, so that means that it went from 10 to 15, so this piece of metal displaced 5 milliliters of water. So there was a difference. 15 minus 10 equals 5 milliliters. This piece of metal is most likely solid. Okay, and so we need to use centimeters. So if it displaced 5 milliliters of water, that must be the volume of this object right here. But since it's solid, we need to say that it's 5 centimeters cubed. Okay, so that's the volume of this object. So we can come over here to our question and put in 5 milliliters. And then if you do the math, 90 divided by 5 is 18. And we see that we have grams on the top, milliliters on the bottom, so our units are going to be grams per milliliter. So the density of that piece of metal is it's 18 grams per, oh, I'm sorry, I messed up here. Again, this was solid, so I should have used my centimeters cubed as I said over here. So it's 18 grams per centimeter cubed. And we look over here, do we set it as an answer choice? We do. It is C. You should not have to guess. Okay, you should have been able to do the calculations. And if you really picked it up yesterday, it's only the second day that we're doing it. So if you picked it up yesterday and got it quickly, that's great. If you didn't, hopefully this example right here showed you, but you're going to have plenty more time to practice, which we're going to do right now. So that's how you calculate density on paper. Okay, but I'm actually going to show you how to also do it in real life. We can actually take the density of any object. Now, every substance has a density, and I want to remind you, okay, density is simply saying how much matter do you have in a certain amount of space. Okay, so you can see that all these boxes here are the same size, but you can see in this box there's more stuff in that space, so we have more mass per volume. Okay, and so this material here is more dense than this material, and this material right here is the least dense. So everything in the universe is made of matter except for energy. Okay, and because it's made of matter, those particles that make up every substance are a certain distance apart. So you can think of density that way as well. How closely packed are the particles that make up a substance? Now, I have a few things here. Okay, I have two blocks here. They are the same size. Now, if you held these, and I'm probably going to pass these around the classroom, just by holding them, you can be able to tell which one is more dense than the other one. Now, they're exactly the same size. Now, you can't tell which one is more dense by looking at them, but by feeling them, you can have a better sense of what the mass is. But each one of these blocks is made of particles. Now, in one of them, the particles, there's more particles than in the other one. Okay, so it could be this one or it could be this one. But the one that has the most particles in the same amount of space is going to be more dense. Okay, but let's see, remember. Oh, we also have like a block here again. Each one of these is going to have a specific density. Now, it doesn't matter. Even if this block right here was this small, or we took off a tiny little piece of it and we measured the density, it would be the same because it's made of the same material. Okay, so the size of the object, as long as it's made of the same material, doesn't affect the density. So let's say I told you to calculate the density of this block right here. Okay, this is a cube. But first of all, we need to write down our formula. We know that density is equal to the mass divided by the volume. Well, so we need the mass of this block right here. So actually, if we come over here, I have a scale here because we use a scale to get the volume of an object. Okay, so I'm just gonna, or the mass of an object. So I'm gonna put my block on there and I'm gonna try to see what the mass is. It's starting to tilt there. Okay, so I know 40 is too much, so 50 would probably be, 40 is too little, so 50 is too much, so it's in between 40 and 50 somewhere. Okay, so I'm gonna move this over here. Come back a little. Okay, it's gonna be, actually I'm right on like 42. Okay, so we'll use 42 grams because you see 40 back there, 2 here. Okay, so let's say the mass of this block is 42 grams. Okay, we've gotten that. 42 grams. Okay, now we get the volume of this block. Now, this block right here is, actually it's a regular object. Okay, it's a rectangular size object. So to get the volume of this, we can simply do the length times the width times the height. Okay, and if we take our ruler and do that, if we measure this in centimeters, okay, one side of this cube is about 2.5 centimeters. So that's 2.5 centimeters. Okay, so let me see, make sure that's right. Yeah, 2.5. Okay, so the length is 2.5 centimeters. Now, since it's a cube, the width and the height of this block is going to be the same. So it's going to be 2.5 times 2.5 centimeters times 2.5 centimeters. Okay, because it's a cube once again. So the length times the width times the height. So it's 2.5 times 2.5 times 2.5. Okay, 15.63. We'll round. Okay, so 15.63 centimeters cubed is going to be my volume. So I can come back up here and I put 15.63 centimeters cubed. Okay, and then I can simply do the math. You can put it in your calculator. 14 divided by 15.63 equals, okay, 2.69. So 2.69 grams per centimeter cubed would be my density of this cube right here. Now, what about this one right here? Okay, they're the same size. Okay, so we know they're going to have the same volume. Okay, so now we should be able to tell which one of these is more dense, even though you haven't held them in your hands yet. So we already know the volume. Okay, so if we want to, let's call this the density of, this was cube 1. Okay, so let's see what the density of cube 2 is. All right, so we can put that back on our scale. I'm gonna just do it quickly. Okay, so actually I'll show you again because we need the mass. Okay, so we're gonna move this one over to over there. Okay, that's not enough, so it's more than 100. Okay, it's probably not 200. Okay, so between 100, it's 200. Okay, so that's 150, 140. Okay, it's between 130 and 140 somewhere, so we move our ones here. Okay, so it's right in there. So it's 132.5. Right in there, yeah. Okay, so we'll use 132.5 as our mass. Okay, because we know here, down here, I move it. We know our density is equal to mass divided by the volume. Okay, we say our mass is 132.5 grams. And we know the volume because this cube is going to be the same size as the other one. So it's 2.5 centimeters times 2.5 centimeters times 2.5. So it's going to be 15.63 centimeters cubed. Okay, so we can put that in our calculator. 132.5 divided by 15.63 centimeters cubed, and we're going to get a density for cube 2 of 8.48 grams per centimeter cubed. Now we can see that even though these are two the same size, the density of cube 2 is more than the density of cube 1. And so even though they take up the same amount of space, this one right here has more volume, or I mean it has more density than this one, or it's more dense. Okay, so if you actually held them in your hand, you'd be able to tell that right away because this one right here, okay, is heavier than this one, even though they could tell they're the same size, but you couldn't tell by looking at them. All right, so that's how you actually calculate the density of an object. But what if you had I asked you to calculate the density of something like this rock, okay? You can't take, the rock is curved. You can't take the length times the width times the height because it's got all kind of, rounded edges and it's not a perfect rectangle. Okay, so what do? Okay, well, the process is the same. Okay, you take your density equals mass over volume. Okay, so we need the mass of this rock. So I'm gonna just quickly put it on here. You've seen it by now. And find out what the mass of it is. Okay, it's not 20. Okay, it's between 20 and 30 somewhere. Come over here. Wait, no, actually it's at 30. It's between 30 and 40 somewhere. Okay, I'll show you. Okay, we're getting there. Oops. Okay, so in interest of saving time, we'll say that it's about 33.3. Okay, we'll say it's 33.3 grams. So let's write that down. Okay, and now we need the volume. Now we can't take the length times the width times the height of this because it's really weird. So now we want to use our displacement method. Okay, so we come over here, and to use our displacement method, we can use our graduated cylinder here. Now in here, I've put, you can't see it there, but let's say there are 170 milliliters of water in there. It's 170 milliliters. Okay, and so if I want to know this, like if I put this rock in here, it's going to displace some of this water, and the volume is going to change. And the amount of change that it shows me is going to tell me what the volume of the rock is. So it's on 170 now. So I put the rock in there, and it goes up to, let's see, that's about 188. So 188. So it went from 170. And then it went up to 188. Okay, that's a difference of 18. Okay, so 18 milliliters was the change in the water, but the rock is solid, so that's also equal to 18 centimeters cubed. So our volume of the rock is going to be 18 centimeters cubed. And so if I come over here and then I type in 33.3 to my calculator and divide it by 18 centimeters cubed, I get 1.85. So the density of this rock is 1.85 grams per centimeter cubed. Okay, so now you can see we've calculated the density of this rock. You can do this for any substance. I mean, obviously, if you had something big, like a car or something like that, you want to get the overall, you'd have to put it in like a much bigger, volume of water or something like that. But you can see now that this is the practical way to calculate the density of an object. You can do this for almost any object. So we're applying what we know, and you simply do it. So if you know that density equals mass over volume, you can do that. Also remember that they may give you, there's three variables here. They may give you one and ask you to figure out the other one, but you should be able to do that by doing your algebraic formula or using our three variable triangle that we've used before. All right, so now you should be able to do your work more quickly. I want you to do the active reading notes. Okay, I want you to do then the reading essentials and just move along as quickly as you can in the student workbook. All right, make sure you go back to the beginning. If you are missing anything, all right, from the very front, you need to do that first. Do everything in order so it builds in a more logical progression and you are learning stuff in a way that it builds on the thing that you just did before it. All right, so get to work. Have a great day.